Question 1. This question asks for the correct electron configuration of sulfur. Sulfur has atomic number 16, so a neutral sulfur atom has 16 electrons. We fill the orbitals in order of increasing energy. First, 1s holds 2 electrons, then 2s holds 2 electrons, then 2p holds 6 electrons, then 3s holds 2 electrons. That gives us 12 electrons so far. Sulfur still needs 4 more electrons, and those electrons go into the 3p sublevel. So the full electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. That matches answer B. The important point is that sulfur has 16 electrons, and the final part must be 3p4. Question 2. This question asks how many unpaired electrons are present in an oxygen atom in the ground state. Oxygen has atomic number 8, so it has 8 electrons. Its electron configuration is 1s2, 2s2, 2p4. Now focus on the 2p sublevel. There are 3p orbitals. According to Hund's rule, electrons spread out into separate orbitals before they start pairing. So the first 3p electrons go into 3 separate boxes. Then the 4th electron pairs with one of them. That leaves 2 unpaired electrons. So the answer is C. Oxygen has 2 unpaired electrons in the ground state. Question 3. This question asks which statement about sublevel capacities is correct. Each orbital can hold a maximum of 2 electrons. The s sublevel has 1 orbital, so it holds 2 electrons. The p sublevel has 3 orbitals, so it holds 6 electrons. The d sublevel has 5 orbitals, so it holds 10 electrons. And the f sublevel has 7 orbitals, so it holds 14 electrons. Therefore, the correct answer is B. S holds 2, p holds 6, d holds 10, and f holds 14. A simple way to remember this is 1, 3, 5, 7 orbitals. Then multiply each number by 2. Question 4. This question asks for the correct electron configuration of chromium. Chromium has atomic number 24. If we follow the normal filling order only, we might expect chromium to be argon, 4s2, 3d4. But chromium is a common exception. One electron moves from the 4s sublevel into the 3d sublevel. This gives chromium a half-filled 3d sublevel. A half-filled d sublevel is especially stable. So the actual electron configuration of chromium is argon, 4s1, 3d5. That matches answer B. The key idea is that chromium is more stable with a half-filled d sublevel. Question 5. This question asks which electrons are removed first when an iron atom forms Fe2+. Neutral iron has the electron configuration argon, 4s2, 3d6. This can be confusing. When we write the electron configuration, 4s fills before 3d. But when transition metal ions form, electrons are removed from the 4s sublevel first. So iron loses the 2 4s electrons. After losing those 2 electrons, Fe2+ becomes argon, 3d6. So the answer is B. The electrons removed first are the 4s electrons. Remember this rule. For transition metals, remove 4s electrons before 3d electrons. Question 6. This question gives the wavelength of light emitted by hydrogen. The wavelength is 486 nanometers. We need to calculate the frequency. The equation is frequency equals the speed of light divided by wavelength. First, convert the wavelength into meters. 486 nanometers is 4.86 times 10 to the negative 7 meters. Now use the speed of light, 3.00 times 10 to the 8 meters per second. So frequency equals 3.00 times 10 to the 8 divided by 4.86 times 10 to the negative 7. This gives 6.17 times 10 to the 14 Hertz. So the answer is A. The key idea is that wavelength and frequency are inversely related. When wavelength decreases, frequency increases.